Hello, my name is Bassem Kamal. I am a student at Faculty of Engineering in Cairo University. This is my LabVIEW demo for ELCN100 Laboratory course with Dr. Hassan Mostafa. This is the spring semester of 2020. The project was to create a digital logic analyzer. So we can go ahead and see the process used as an example. In the left part of the front panel, there is an example for the process where there is a tank with a fluid that's being heated by a heat source. To measure the temperature of the fluid, a transducer was installed to it. This transducer is a thermocouple which returns a voltage value corresponding to the measured temperature. So to study the behavior of this process, this thermocouple hypothetically was connected to the data logger at input 1. Now this data is available in the graph for further analysis to transduce the measured voltage to temperature. It was necessary to search for real thermocouples catalog and take some voltage temperature pairs to obtain the equation that fits that behavior. This equation would be used to approximate the temperature the fluid has according to the voltage the user is sending. Now the data is here. It's possible to take some control actions using this info. In this case, the action to take is to turn down the heat process when certain temperature value is reached. For this, numeric control is used to set the maximum temperature value allowed. If the thermocouple senses that the temperature has reached its maximum, the program will immediately tell the heat source to shut down. We put it 700 for example. If the temperature reached 700, the program will shut down automatically. In this case, as there was no real transducer or data acquisition device, the input were simulated by controlling the knobs. Here, to simulate an input data, in this case in millivolts, the user should rotate the knobs to give some input values. For this project, inputs 1 to 8 were used to show some specific features. As said previously, the user can control the input data by controlling the knobs, and that input values will be shown in the graph next to it. The upper graph is the one which is showing the values passed from the user. So when the user changes the input values, the corresponding line to the input is going to respond and will be plotted in the graph. This graph is plotting voltage in millivolts versus time in seconds. Input 1 is a linear, meaning that the value given to the knob will be a corresponding value in the y-axis in the graph. The inputs from 2 to 7 are used for representation of a sine signal corresponding to a periodic phenomenon, for example pendulum motion or vibration, etc. In this case, the knob controlling input 2 is used for controlling the frequency, the knob controlling input 3 for controlling the amplitude. The knob controlling input 4 is for the DC offset, and the knob controlling input 5 is for the noise amplitude, and so on. 6 for the phase and 7 for the cutoff frequency. The middle graph is filtering the data. In this project, the only signal that is being filtered is the one I control from these knobs for illustration purposes. Now we can see an example. So now let's see an example of it working. Here I can control the heat that the transducer is going to sense, and I have set the maximum temperature to 700, but at first I must raise the cutoff frequency before starting, otherwise it won't run, it will give an error. So now to produce a signal, I can give it a frequency and amplitude. Of course, it appears on the uppermost graph on the right, and I can control now its DC offset to make it in the middle. lower the frequency a bit to be more obvious. Now I can add some noise to it using the knob controlling the noise amplitude. As you can see, the noise has appeared in the upper graph, but in the lower graph it's filtered. Thanks to the filter, in this case it was used a low pass filter to cut off the frequency. You can control it from the cutoff frequency knob. And I've raised the heat to 700, and as you can see the program stopped automatically. And here of course you can see the frequency domain of input 2. And that is my project. Thank you.